All right, today we're going on a bit of a mathematical treasure hunt. We're going to uncover a secret pattern that's hiding in plain sight, inside some of the most basic shapes you can imagine. A pattern that ties every single one of them together.
So let's just kick things off with a question. You look at these two shapes, a simple, basic triangle, and then this complex 10-sided decagon. I mean, they look like they're from different worlds, right? But I promise you, by the end of this, you'll see they're basically built from the exact same blueprint.
Now, to find that secret connection, we first need to lay down our foundation. Let's start with the absolute basics.
So what even is a polygon? It sounds like a fancy word, but it's really just the name for any closed, flat shape that's made up of only straight lines. A triangle, a square, a stop sign. Yep, all polygons.
Now here's the really cool part. To unlock the secrets of every single polygon out there, from a simple square to a crazy shape with 1,000 sides, we only need to totally understand one of them. It's kind of like having a master key.
And here it is, 180 degrees. This number, this is the single most important fact for our entire investigation. It's the sum of the angles inside any triangle, every single time. This is the rock, the foundation for everything we're about to build.
So, how can this one simple fact about triangles help us with everything else? Well, we're about to uncover a pattern that works for everything, and we're going to do it by, you guessed it, building with triangles.
First up, the next simplest shape after a triangle, a quadrilateral. And that's just anything with 4 sides. A square, a rectangle, a trapezoid. It really doesn't matter what it looks like.
Here's a super simple 3-step method that works for any polygon you can think of. 1. Pick any single corner. The technical term is a vertex. 2. From that one spot, draw straight lines, we call these diagonals, to every other corner you can reach. And 3. Just count up the triangles you've made.
And for our 4-sided shape, what do we end up with? Exactly 2 triangles. See, this is what I'm talking about. Since we know each triangle is 180 degrees, we just multiply. 2 times 180 gives us a total of 360 degrees for all the angles inside.
All right, let's keep this going. Next up is the pentagon, with its 5 sides. Now that you know the method, can you guess how many triangles we're going to find inside this one?
If you guessed 3, you are spot on. From one corner, we can make exactly 3 distinct triangles. So 3 times our magic number of 180, and we get a grand total of 540 degrees for the pentagon's interior angles.
Okay, let's dive into this. Let's just pause for a second. Are you seeing the pattern start to show itself? There's a really clear connection between how many sides a shape has and how many triangles we can make.
Let's just lay it all out here in a table. A 4-sided quadrilateral gets us 2 triangles. A 5-sided pentagon, 3 triangles. A 6-sided hexagon gives us 4 triangles, and it just keeps going. You see the relationship, right? For any of these shapes, the number of triangles is always just 2 less than the number of sides.
And that little discovery right there, that brings us to our big reveal, the universal angle formula. This is that aha moment where the whole puzzle just snaps into place.
So what is that secret rule? Let's just spell it out.
Here it is, and it's so beautifully simple. If we use the letter n to stand for the number of sides a polygon has, then the number of triangles you can make inside it is always, and I mean always, n minus 2.
And that gives us this incredibly elegant and powerful formula. The number of sides minus 2, all of that multiplied by 180 degrees. This is it. This is the key that unlocks the interior angles of any polygon in the universe, whether it has 10 sides or 10 million.
So what does this powerful little formula really tell us? Let's zoom out for a second and look at the big picture, taking this idea from these simple shapes all the way out to infinity.
So here are the key things to remember. 1. Every single polygon, no matter how complex, is really just a bunch of triangles stuck together. 2. The number of triangles you can make is always 2 less than the number of sides. And 3. That means every time you add a side to a polygon, you're also adding another 180 degrees to its total interior angles.
And that leaves us with one last kind of mind-bending thought to chew on. As you keep adding more and more sides to a polygon, it starts to look less jagged and, well, more round. A polygon with 1,000,000 sides looks almost exactly like a circle. So what does our formula, n minus 2 times 180, suggest about the sum of the angles inside a perfect circle? It's a fascinating question to ponder. Thanks for joining us.